In this video, we're going to look at how to write an equation of perpendicular lines. You need to remember that the equation of a straight line comes in the form y equals mx plus c, where m is the gradient, which describes the steepness of the line, and c is the y-intercept, which is where the line crosses the y-axis. If you can't remember how to write an equation of a straight line from the graph, please revise this first, because you will find this video very difficult if you can't remember how to find the equation of a line from a graph. And now we're going to have a look at equations of perpendicular lines. Remember that perpendicular means that the lines cross at 90 degrees. And in terms of gradients, we need to have gradients which are negative reciprocals. And it may sound complicated, but it's actually quite straightforward. So this is what it means. I have those two lines, y equals 3x minus 4 and y equals negative third x plus 1, and I know that those two lines are perpendicular because the gradient of the first line is 3, the gradient of the other line is negative, so I have opposite signs, and it's 1 over 3, so that's a reciprocal. Okay, so that's the gradient here, and that's the gradient here. So you can see that that is a reciprocal because that's 3, that's 1 over 3, and the second gradient has a negative sign in front of it. Also, the product, so that means when I times those two gradients, I will get minus 1. And the next pair, again, the same thing. Remember that sometimes you may need to rearrange the equations, but I know that the first gradient is minus 2, the second gradient is a half. So when I multiply the product of the gradients is minus 1. And then for the last one, again, you need to rearrange the equations for you to be able to identify the gradients. So you can see that for the first one is minus a half, then for the second one is 2. So when I times the two gradients, I get minus 1. You can have a go, okay, and see or show that these each pair of these lines are perpendicular. And these are the solutions. Now here you are asked to write an equation of any line that is perpendicular to the given lines here. So remember, you need to identify the gradient of the lines given first, then work out what the perpendicular line's gradient should be, and then write an equation. So for the first line, it's the gradient is 2. So the line that is perpendicular to it will have the gradient minus half. So it could be, for example, y equals minus half x plus 6. For the second line, you need to rearrange this equation first, identify the gradient, and then write down an equation of a line that's perpendicular. Okay, the gradient in this case, okay, in the line that's given is minus 2. When you rearrange it, you get the gradient that's minus 2. So that means the gradient of the line that's perpendicular to it needs to be a half. So it could be, for example, y equals a half x minus 2. It could be y equals a half x plus 10. It doesn't matter what the y-intercept is, as long as the gradient is a half. And the last one, again, you need to rearrange that equation first to identify the gradient, and then work out the gradient of the line that's perpendicular to it. Okay, so when you rearrange the original equation, you'll get that the gradient is minus 10th or minus 0.1. So that means that the gradient of the line that's perpendicular will have to be 10. So it could be y equals 10x plus 5. It could be y equals 10x minus 2. It could be y equals simply 10x. Now, just like with the parallel lines, okay, we might be asked to write an equation of a perpendicular line that goes through a certain point. Okay, so I have the equation and I have the gradient here. So first thing I need to work out is the gradient of a line that is perpendicular to it. So I need to remember that I need to have an opposite sign. So this one is positive, so I need to have a negative gradient. And then the reciprocal of a half is 2. Okay, because that's 2 over 1, which is simply 2. So I know that the gradient will be minus 2. And then I still need to work out what the y-intercept is. And just like with parallel lines, okay, sometimes this point here might be a y-intercept. As you can see, the value of x is 0, so this point is actually the y-intercept. Okay, so I know straight away that this equation will be minus 2x plus 7. I could use substitution, okay, so I know the value of y is 7. So if I'm to substitute it, then I'll have 7 equals minus 2 times 0 plus c, so that means that the value of c is 7. I can substitute it back into the equation. Okay, and it's important you know how to substitute, because sometimes the equation or the coordinates of the point is when the point is not on the y-axis, so you need to actually work out through substitution. Like in this example here, okay, I would like you to pause the video and have a go. Okay, so first you need to work out the equation, sorry, not the equation, the gradient of the line that is perpendicular. So if this one is a half, then I need minus 2 again, okay, but this time, this point, okay, because I know that the value of x is minus 2, so that means this point is not on the y-axis. These are not the coordinates of the y-intercept. So I need to now use substitution to work out the value of c. So the value of y is 9, and then the value of c is negative 2. So 9 equals, now negative 2 times negative 2 is positive 4. You add c, and that means that the value of c is 5. And I can put it back into the equation here, which is going to give me the equation y equals minus 2x plus 5.